Alright, so we're going to go on with Unit 7 notes here. So let's start off with reviewing our right triangles. So with Pythagorean theorem, basically the longest side, or hypotenuse, always gets its own side equal sign, whereas the two short sides, when we square them and add them, are equal to it. So if I set this first problem up here, I see x is my hypotenuse. It's across from my right angle. So if I square the short two sides here, let's see, that'd be 36 plus 16. Again, GeoGebra will handle these calculations as well. 52. And if I take the square root there, and again, with length, we're always going to be moving in positive. 52, well, that would be 2 and 26. 2 and 13, so our simplified version here, I think I'm going to pair 2s, do 2, and I'm left with 13 on the inside. Here we see across from our angle the 11, so I'm squaring up to the short side. Good next, 9 is equal to 121. And if we subtract, let's see, so if we take away 40, that gives us 81. It's going to be 72, so taking our square root. We break that down, we get 2 and 36. Break that down, we get 2 and 18, 2 and 9, 3 and 3. So I can take out a 2 and a 3, and I have a 2 left over. 2 times 3 times square root of 2, so that would be 6 root 2. One more here. So I see my 11's across from that, so it gets its own side. So I have x squared plus, let's think of this in parentheses here, square root of 65 squared equals 11 squared. So it's x squared plus square root and squared cancel. GeoGebra will attest to that. 1.1, so if we subtract 65, we'll get 56. And then if we square root it and break it down, so that's 2 and 28. Give me 2 and 14, and 2 and 7. So I can take out a pair of 2's, and I'm left with a 2 and 7 on the inside. So that would be x is equal to 2 square root of 14. Alright, moving on down. Okay, here we are using our theorems here. So this is again review. So we're just going to kind of move through these quickly of solving these. So, key idea with 45-degree triangles. The two short sides are the same, and the hypotenuse across from 90 is equal to square root of 2 times x. So here I see what I'm getting is across from a short side. So these are both just x, and this is root 2x. So I know x is equal to 6, so I could go ahead and say this side is 6, and this side would be root 2 times 6, which is 6 root 2. Now this one, and again, these are diagrams that will be on the board when you test, so we're just setting them up from here. So across from my 60, this is root 3x, and then across from my 90 is 2x. Oh, this is 60, this is 30, and that one's just x. So plugging in, if I had 5 here, that'd be 5 root 3. And here, 2 times 5 would give me 10. Let's try these two as well. Okay, so across from my 45, so those are just my x's. And then it's root 2x across from my 90. So I know x is equal to 4 root 3. So if I plug in here, that would be root 2 times 4 root 3. So if we multiply our square roots, we would get 4 square root of 6. So across from my 90 is 2x. Across from my 60 is root 3x. And then across from my 30 would just be x. So here if I solve this, I'll find x is equal to 4. So this would be 4. And this would be 4 root 3. So at this point, these are going to be left up to optional practice. So I would suggest solving each of these 3 problems and then checking with me to ensure your answers are correct. So pause the video now in practice with these three problems. All right, let's check these two examples real quick together, and then the next three will be left to optional practice. So if we set up our 45, we know we have x and x, and this is root 2x. So to find my x, I have to divide both sides by the square root. So I get x is equal to 10 over square root of 2. To get rid of that in the denominator, we multiply the top and bottom by that square root. So if I multiply top and bottom by square root of 2, on the top I'm left with 10 root 2. On the bottom, square root of 2 times 2, the root 2 is just 2. And I could simplify, well 10 over 2 is just 5, so I get 5 root 2. So that would go in both of these spots. Here, setting up, so across from our 90 is equal to 2x. Across from my 30 is just x. And then here is equal to, across from my 60, root 3x. So dividing again, we'd have x is equal to 7 over root 3. Multiplying, I'd get x is equal to 7 root 3 over 3. And those don't reduce, which we could check using fraction text in GeoGebra without typing in the square root. So I'd just do fraction text 7 divided by 3, and it would spit out 7 over 3 again. So if we plug in, this side is just going to be that 7 root 3 over 3, because it's just equal to x. Here it would be 2 times that. So in a calculator, what I would suggest doing in GeoGebra is doing fraction text, 2 times parentheses, 7 divided by 3 parentheses, hitting enter, and you will arrive at 14 over 3. And we keep our square root on the top. At this time, I would suggest doing these three problems on your own and then checking with me to ensure your answers are correct. So pause the video now and complete these three problems. Alright, moving on to some trig functions here. So we're going to deal with 6 trig functions here. So SOHCAHTOA, what this stands for is sine is opposite over hypotenuse. So we're going to need to memorize these. So SOHCA, adjacent over hypotenuse. And TOA, which is opposite over adjacent. Reciprocals mean we just flip them. So sine and cosecant go together. So I flip it. Cosine and secant, flip it. Tangent, cotangent, we just flip it over. Alright, so what's really important here is how we label that OA and H. The key idea here is we start with what our theta is, or whatever our angle in question is. So if I draw a line directly across from it, that side is always my opposite. So here, if I drew a line across, opposite. If I drew a line directly across, opposite. The next thing I was doing is drawing a line from your right angle. That's always going to be my hypotenuse. So across from right angle, hypotenuse. Across from right angle, hypotenuse. Those are the two we can always label easily. And then what's left, what other side is there, that's just our adjacent. So whichever side we haven't labeled yet becomes our adjacent side. Alright. Now we're going to figure out all 6 trig functions from these. We're going to figure out all of our fractions. And if we have any square roots in the bottom, we will need to simplify. So let's go ahead and label first. So across from this angle, if I draw a line straight out, there's my opposite. Across my right angle is my hypotenuse. Here's my adjacent. Across from here, my opposite. Across from the right angle is my hypotenuse. And then here's my adjacent. So in the first example here, we're given all 3 values. So sine, so, that's O over H. Ka, A over H. Toa, over A. And my reciprocals, notice they're lined up here. So I flip it, and flip it. Alright, so O over H, that's 15 over 17. A over H, that's 8 over 17. Over A, 15 over 8. Flipping them over here. So this is pretty easy when we have just all nice whole numbers. It's pretty easy as well when we don't, just maybe a couple more steps. Alright, so here, we notice first off, we have an opposite side without a value. So to solve for it, we're going to use our Pythagorean theorem. So my 2 short sides, so I'm just going to call this O, let's put a line. Let's put a line through all of our O's, just so we know that they're not zeros. So here I'd have my opposite side squared plus my A squared. So always think of this formula for our specific case here of trig. It's the same as Pythagorean theorem, just rewritten with the variables we use. And again, if you use that O with a line, it won't get mistaken for a 0. So my A squared is 2, and then my hypotenuse there, my A squared, is square root of 10 squared. So that gives me 4 is equal to 10. Subtracting, I'd get O squared is equal to 6. And the square root there just gives me square root of 6, which won't break down. So, sine opposite, which we said is square root of 6 over hypotenuse, so square root of 6 over square root of 10. Let's go ahead and write them out first, and we'll simplify if we need to. So A is this, there's my hypotenuse, and O over A, flipping them. Alright, so I'm going to get a different color pen here just so you can see some simplification. Alright, so first thing I look at. Now, once I've written all of them out, I got to start cleaning some stuff up. So I have a square root of 10 in the bottom, so I'm going to multiply it by top and bottom. So I'm going to get the square root of 60 over 10. Here I multiply again by square root of 10 on top and bottom, so I get 2 root 10 over 10. And this one will simplify, so 2 over 10 reduces to 1 over 5, so it's just root 10 over 5. And again, GeoGebra, fraction text, 2 divided by 10 gets us at 1 over 5. We could write the 1 here if we want to, but don't need to. This one's already good, no square root in the bottom. Here, root 6 in the top and bottom. So I'd get square root of 60 over 6. This one's good. This one, our root 6. Checking with our fraction text, we find it simplifies to root 6, or 1 root 6 over 3. So not necessarily harder, just to add a bit more work. Alright, moving on. At this point, you should go ahead and try these two problems now, and once they're completed, come check them in with me. So pause the video at this time and begin these two problems. Okay, so here we have find the values of the trigonometric function indicated for each angle measure. This is where we're going to go ahead and employ our unit circle. So by having the unit circle, we avoid a little bit of that work we need. So we're actually going to go ahead and just do these utilizing the unit circle. So at this point, you can go ahead and take out your completed unit circle, which we'll have memorized and gotten down pat at the beginning of this unit. Once we do that, it makes finding all this a bit easier. So sine 30, when we look at our unit circle, 30 is in order of cosine, comma, sine, so alphabetical. So at 30 degrees, we have the coordinate of square root of 3 over 2, comma, 1/2. So sine of 30 is just 1/2. Tangent of 45. Well, tangent is defined as sine over cosine. So that's 45 over 45. So if we plug in from our unit circle, at 45, sine is root 2 over 2. And cosine is also root 2 over 2. Since these are the exact same number on top and bottom, we know they cancel out to just give us 1. Now, cotangent of 60. Well, tangent is sine over cosine. Reciprocal, cosine would be 60, so we flip it. So instead of sine over cosine, it's cosine over sine. Using the unit circle at 60 degrees, we look and we see that cosine here is going to be our first value, which is 1/2. So this is equal to 1/2 over sine at 60 degrees is root 3 over 2. So now these aren't the same number, so we can't just cancel the 1. So to work with these, I would take my top fraction and multiply by the reciprocal. So I flip over the bottom one. Multiplying across, we get 2 over 2 root 3. Our 2's cancel out, so I'm left with 1 over square root of 3. Getting it out of the denominator, we get 1 root 3, or just root 3, over 3. go ahead and do these three together here. So secant of 60. Well, let's see. Secant's not on the unit circle. So let's see what I can do instead. I know that secant goes with cosine. So what I'm going to do is rewrite this as 1 over cosine of 60. Utilizing my unit circle, I look at 60 degrees and realize that cosine there is equal to 1/2. So this is 1 over 1/2. Using our reciprocal again, because we have a fraction at the bottom, or GeoGebra because there's no square roots involved. This would be 1 times 2 over 1, which is just 2. Cosecant, well, we know that goes with sine, so this would be 1 over sine of 45. Using our unit circle, we realize that that's going to be root 2 over 2. So the reciprocal yet again. So this is just 2 over root 2. Getting it out of our bottom, as we've done a couple times already, gives me 2 root 2 over 2. Cancels, so I just get square root of 2. And cosine of 30, referencing our unit circle, we'll see that that's just root 3 over 2. Alright. Okay, so now we're going to find all 6 given some information. So key idea here is going to be drawing out our circle. So we need to think about positives, negatives, and all that wonderful stuff. So right here we have that sine is equal to 4 over 9. Well, if we remember our SOHCAHTOA, sine is opposite over hypotenuse. So I think of my formula, right? So I know that O squared plus A squared is equal to H squared. And we don't have an A because all we know about is sine. So if I plug in here, that's 4 squared, don't know what A squared is equal to 9 squared. So that would give me 16 plus A squared is equal to 81. And if we subtract 16 from both sides, we get A squared is equal to the square root of 65. So it's not divisible by 2, not divisible by 3. If we try dividing by 5, we get 5 and 13. Those don't break down. So A is just going to be that square root of 65 because we've taken our square root. So as I plug in O, we already know here our sine is 4 over 9. Flipping it, cosine is A over H. Tangent, O over A. Flipping here. And flipping here. Now our simplification, right? So we see some square roots in the bottom, so I need to do my check. Good, good, not good. So if I multiply both top and bottom by square root of 65, we arrive here. That won't reduce. We're good here. If I multiply both top and bottom by square root of 65, we're good here. We check in GeoGebra, doesn't reduce, and this one's good. Alright, so let's think what we know here. I see secant is by cosine. It's the reciprocal, so this is actually H over A. So I don't know my opposite. So if we go ahead and plug in here, and then 17 squared gives me 289. Subtracting 100 gives me 189. So let's see here if we can break this down. So when I take the square root of both sides, I've got to check if I can break it down. Not divisible by 2. We check, not by 3. Oh, it is divisible by 3. So I divide it by 3 here, and then I would get, so we factor this thing down here, I'd get 3 and 63. 63 divisible by 3, that gives me 3 and 21, and then 3 and 7. So if we break that down, we see we take out a pair of 3's, and we're left with square root of 21, because of 7 times 3. Alright, so let's go ahead now. We have our opposite side and write a trig function. So this one is O over H. A over H. A. Moving over here, we flip them. Oops, wrote that one wrong. Flipping again. Which makes sense, we already had that one. Then here, it'd be 10 over 3 root 21. Here, square root's not in the bottom. We're good, we're good, we're good. This one we multiply top and bottom by just square root of 21. So on the top, I'd have 17 square root of 21. And then I do 3 times 21 on the bottom. The square root of 21 times square root of 21 is just 1. So that gives me 17 over 63. And that one is not going to reduce. We're good here. Square root of 21 on top and bottom gives me 10 root 21 over 63 again. And we know that that will not reduce either. So we're good there. At this point, you guys should go ahead and try this problem, show all your work, and then come check it with me to ensure you've got everything down. So please pause the video at this time and complete the following problem. All right, so good there. All right, now this one, here's some steps to solve. So first, we're going to kind of use a point to get an idea here. So we're actually going to skip over this part, and let's just go right into some example work. All right, so for these next, we'll do two, let's see here. We'll do 2 together and leave 1 up to optional practice. So this one is something you're going to do on your own. We'll do these 2 together. So we're given a point, and we need to find all 6 trig functions from it. Move on here. We have our 2 points. So first off, we need to think a little bit about where these points might be. So if we look, sorry, it's frozen up. As we're looking, pretty much we know our x's and y's are positive. So x's and y's are positive here. So this is positive xy. To the left, this is negative x, positive y. Down here, everything is negative in quadrant 3. And in quadrant 4, my x is positive, my y is negative. At this point, this should be 100% review, but if you don't know that, please write down the diagram, as we'll be using it. All right, so here I have my point is at positive 3, positive 4. So, positive 3, positive 4. So if I think about these are all going to be different variations of triangles. So kind of a general diagram we're going to use here is going to look something like this. So each of our triangles are going to follow this type of bow tie pattern. So if we use that, we know we're in quadrant 1, so my triangle is going to look something like this. Our angles are always going to come from the middle, and then our right angles are here. Let's go ahead, and I'm actually going to draw a better version of this diagram just so we can have that down. I suggest you draw this big somewhere that you have it. So here's our x, y's. So here's our triangles. So they're always going to be one of these 4 for this unit. Whenever we deal with any of these, it will be one of these. And our angles always come from the middle. And what it looks like right angles are right angles. So these are right angles and these. So we'll utilize that to solve our problem. All right. So here, I know that this length is 3. So you can think of this thing at 3. And if my height is 4, that means this is 4. So if we look at our labeling, we have our O. This is my H, which I don't know yet. And then my A is what's left over. So to solve for this, we'd utilize the Pythagorean theorem. So I'd have 3 squared plus 4 squared is equal to our H squared. And from solving, we'll realize H is going to be equal to 5. Like our hypotenuse is always going to be a nice positive number. So now that we have those, we can go ahead and set up our different answers. So O over H, that's 4 over 5. A over H is 3 over 5. O over A. And then we do our flips. nothing too challenging, just a little bit different way of doing the problem. All right, let's do this one here. So we have two negative numbers here. So if I think about that, that means I'm in my bottom quadrant there, so that third quadrant to the left. So I'm going to be dealing with this triangle. -1 refers to my x value, so that's here. -4 means my y, so that's here. We go ahead and solve this. Make sure when you square your negative numbers, you put parentheses around them, otherwise you'll get the wrong value. We're solving for our h again. Notice every time we have one of these problems, we're always solving for h. So this will be 1 plus 16 is equal to h squared, and we'll get h is equal to the square root of 17. So h, our angle is always in the center, so this is my O, and there's my A. So sine -4 over square root of 17, cosine -1 over square root of 17. Over A, that would be -4 over -1. Cosecant, the negative we can always just write on the top since there's just one of them, it doesn't make a difference. But if you leave it on the bottom, that will suffice for an answer as well. Alright, so let's go ahead and simplify these. So here I have the square root on the bottom, so I multiply on the top and bottom. That'll give me -4 square root of 17 over 17. That will not simplify any further. GeoGebra will check it. Here, I'd multiply on top and bottom and get negative square root of 17 over 17. Here, no negatives or square roots, but if we simplify, this is just 4. Here I'm good, and this one, good. So at this point, go ahead and try this problem on your own, and once you're complete with it, come check with me to ensure you've done it correctly. Make sure you're using the right triangle. So positive x, negative y, we should be in this location, with a 5 and a -7 here. Alright. Moving on. So here we're dealing with a couple different vocab words. Let's go right into examples here. So standard position. Now, if I think about these, each of these is a right angle. So this is 90 degrees, 180, 270, and 360. So writing those in first is always a good starting point when we're asking to sketch where an angle resides. Go ahead and get all those in first. Alright, so for this first one, 120. Well, that's between 90 and 180. So it's going to be somewhere in here. 200 is between 180 and 270, so somewhere in here. And 290 is between 270 and 360, so somewhere in here. And that's about it for those. Alright, coterminal, basically it means we have a kind of an angle that ends in the same spot, just a different number. That comes from the idea that we can keep going around this circle over and over by adding 360 degrees. So if I started at something like 10 degrees, I could keep adding 360 and it would represent the exact same angle. Alright, so coterminal -35. Well, if we think about this, instead of going up to get our positives, -35 would be somewhere down here. So to figure out what that would be as a positive angle, I would add 360 to it, which would give me 325 degrees. So coterminal angles, we want to find positive angles from that. So if we start with a negative, we're going to add 360. So here I have a negative again, so I'm going to add 360. And that'll give me positive 130. Now here we have a positive angle. So instead of adding, I'm going to subtract 360. Because we need all of our answers to be positive numbers between 0 and 360. So 515 minus 360 gives me 155. It's now a positive number between 0 and 360. Here we start with a positive, so we're going to subtract. We get 494. It's not quite small enough yet, so we're going to subtract 360 again until we arrive at a positive number between 0 and 360. I get to 134, so I'm good there. Alright, so negatives mean add, so we're going to add 360 here, and we will get positive 260. add 360 because we had another negative, positive 20. Here we're subtracting 360, and we get 335, so that's between 0 and 360. The last one, if we subtract it one time, we get 880, so we're going to minus 360 again. We get 520 minus 360 again, and we'll get to 160. So we can subtract it more than once, as we've seen before. Okay, radians are just another way of doing degrees. So it's just a different measure. We'll talk about how to convert. So, going from degrees to radians. If I go this way, I'm going to take my degrees. So let's go ahead and throw all these over 1. And I want to go to radians. Actually, you know what? Let's make this easier. Alright, so in general, how we go from degrees to radians is we divide by 180. So in GeoGebra here, we want to get a nice reduced fraction, so I'll do the first one, and the left you guys can do the same thing. So we have 30 divided by 180, so we want to use our fraction text as always. So let's do fraction text, 30 divided by 180, that's just 1 over 6. So I have 1 over 6, and we said our second step here is pi goes on top. If I do 45 divided by 180, I'll get 1 over 4, pi goes on top. 120 divided by 180, GeoGebra gives us 2 over 3, pi goes on top. And 225 divided by 180, we get 5 over 4, and pi goes on top. So again, that's definitely a formula I'd write down, the divide by 180, pi on top, when going from degrees to radians. Going the opposite way here. So for this one, to go from radian to degrees, we're going to multiply by 180 over pi. So let's go ahead and set all those up. So notice it's going the opposite way here. Another formula I definitely write down. So one thing we're going to notice here is we have a pi on top and bottom. So they actually are going to cancel out. So on each of these, our pi's cancel, which makes sense because in degree measures, we never have pi involved. So with these simplified to 3 times 180 over 4, 7 times 180 over 6. There's nothing else, there's just having a 1. So it's 1 times 180 over 2. Here'd be 5 times, 5 times 180 over 12. So, if we're in GeoGebra, we're going to type exactly how it looks. So let's get rid of what we have. So we have 3 times 180 over 4, so I'll show one example in here. 3 times 180 over 4. And we get 135. Degrees. This one would reduce to 90 degrees. And 7 times 180 over 6 gives us 210 degrees. And lastly, 5 times 180 divided by 12 gives us 75 degrees. So again, those are just formulas to keep handy while working through these problems. Moving on. Alright. So, working through these now, this is actually, I believe, our last section here. We'll skip over these reference angles at the end. So let's just go ahead and work through these. So, quadrant signs and trigonometry. A couple ways to think of this. Our first acronym here is all students take calculus. So all students, you know what, we're going to skip this, and we're going to do it a better way. Not necessarily a better way. If you've already learned the all students take calculus method, you are more than welcome to use it. I prefer to go ahead and just kind of think through it here. So, our first quadrant is represented up here. So this is Q1. You'll see me use those as opposed to Roman numerals. So this is also just quadrant 1. So it's this. Quadrant 2, otherwise known as this. Quadrant 3, otherwise known as this. And quadrant 4, otherwise known as IV. Alright, so first thing here, we want to think about what's positive in each. So if we remember our unit circle correctly, all these coordinates are deemed as cosine, comma, sine. So utilizing our unit circle, which we will have on the exam, is we look in the first quadrant, we see cosine and sine are all positive. So that means I have, if we just go in the usual order, so cosine, cosine, tangent. And then our other three here, we have cosecant, secant, cotangent. So this is something I would suggest doing as I'm taking a test. I would write all these out. So we're going to identify the positive and negativeness of all three of these just by using a few key ideas. So this is a diagram I would definitely be writing down because it's going to prove incredibly useful as we're going through practice and taking our tests. Okay, so in the first quadrant, if we look at a unit circle, everything, all my coordinates on the outer rim are positive. So I know sine and cosine are positive. These are just the reciprocals, so if these are positive, so are these. Now, tangent is defined by sine over cosine. So if I divide two positive numbers, I end up with a positive. If this is positive, this is positive. So you'll notice the signs on these always match with these. Now in quadrant 2, here I have negative cosines and positive sines. So let's think here. Sine is positive, that means cosecant is positive. Cosine is negative, so secant is negative. Tangent is sine over cosine, so a positive divided by a negative is negative. If this is negative, so is this. Quadrant 3, this is where we have all our negatives, all of our cosine and all of our sine values are negative. So sine and cosine are negative. If these are negative, so are these. Tricky part here, tangent. So if I do sine over cosine, well, negative over negative gives me a positive. If this is positive, so is cotangent. In quadrant 4, our cosines, our x values are all positive, but our sine values, or y values, are all negative. So I have negative sine, positive cosine. Negative means negative, positive means positive. And if I think of my division, a negative and a positive give me negative. So this will be negative as well. Now, using that diagram, we're going to answer these questions. So, first, sine is greater than 0. That means it's positive. Cosine is less than 0. It's negative. Tangent greater than 0 means positive. Sine less than 0, negative. Tangent less than 0 is negative. Cosine greater than 0, that means positive. So we're going to answer each of these questions individually. So here I am looking at places where sine is positive. That's only 2 quadrants. So if I look, it's positive here and here, negative in here. So that means I'm either in quadrant 1 or 2. So quadrant 1, quadrant 2. But now I want cosine to be negative. So if I look, it's positive here and negative here. So my answer would be quadrant 2. Tangent is positive. So let's see, it's positive here in quadrant 1. And it's positive here in quadrant 3. Now I want sine to be negative. So sine is negative, let's see, it's not here, not here. I know my answers are 1 or 3. So it's not negative here, but it's definitely negative here. Therefore my answer, quadrant 3. Alright, tangent negative. So I see that's in quadrant 2 or quadrant 4. Cosine positive, well, I'm looking at 2 and 4. It's not positive here, but it is here. Therefore my answer, quadrant 4. Use the same strategy and the same diagram to answer the next 3 problems. Once you've completed these, ensure that you check them in with me and then you're good to go to move on. So pause the video at this time and complete those problems. Right, moving on. Okay, this is going to be our last 4 problems. Like I said, we'll skip over reference angles for the purposes of this unit. Alright, we're going to need some diagrams. We're going to figure out where things are. Alright, so here we're given a lot of things about different degrees or where things are positive. So you're going to use a lot of that diagram from above. Alright, so we're going to do 1 in this one and then 2 in the next one. Okay, so I know sine is 3 over 5. So I got my opposite and my hypotenuse. That's a good start, right? Now, it says I'm between 90 and 180. So if we use that, okay, this is 90, this is 180. So I know I'm somewhere in here. So again, we're dealing with those same 4 triangles we talked about. It's my angle. Oops. So my opposite is 3. So I go to my opposite side. That's a 3. My hypotenuse is 5. Well, it's my right angle. So here's my hypotenuse at 5. I need to find my a. So first I'll do Pythagorean theorem. So o squared plus, no, I put a 3 there. A squared equals h squared. So I'd have 3 squared plus a squared, 5 squared. When you solve this, you'd have 9 plus a squared equals 25. You'd subtract it, 16. The square root of 16 is 4. So my a is going to be 4. Now, we're just writing that fractions. So sine over h, cosine a over h, o over a, and we do some flipping. And we're good to go. So you'll notice all these problems are really similar. They just give us slightly different information. Let's go ahead and do this one here. So cosine, I know that's a over h. One quick thing I just forgot to mention and realize now. Looking at where we're at, is this a positive or negative number? If you said negative, you're correct. So since we're in this general area, this should actually be as a is equal to negative 4. So what we're going to do is just change all those 4's to negative. So negative here, negative, negative. So again, just something to think about when we're going to go ahead and do those is make sure we're labeling them correctly based on what quadrant. Since we went to the left here, it's negative. Y is still positive. And again, we can reference those.
So finishing up part 2 of our video here, so we found our cosine and adjacent our hypotenuse. Very correct, they're negative here. So as we move through here, we know we're between 270 and 360. So using a few of our diagrams, we know that gives us this triangle. So moving on through, we have our opposite side, which we don't know yet. Our hypotenuse is going to be 13, and our adjacent side here is going to be 5. Some Pythagorean theorem here, so I'll leave that up to you guys to solve, as we've done it a few times by this point. We will find that our adjacent side, or our opposite side here is 12. Since we're down here, we know that our y value, our opposite there, is going to be negative. So setting these up, we have opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and then going ahead through and flipping these. We are good to go. So nothing too challenging there, just kind of going through. Our last 2 problems of the unit are going to be a tad bit different, but not much harder. So here we're just told to figure out our quadrant based on what this is. So if we use our diagram above, we know that cosine being greater than 0. That narrows us down to either quadrant 1 or quadrant 2. Here we're given a negative, so adjacent over hypotenuse. Now, we know one thing, that hypotenuse, because of the way we find it, can never be negative. So we want to think of this negative being with our top number here. So that means I need to plot our points. So if I want my adjacent side to be negative, that means I'm going to be to the left. So we're down here somewhere. So I know I'm going to the left negative 3. Now, we said our choices were quadrant 1 or 3. So by default, I have to be in quadrant 2. We also know our hypotenuse is 17. So Let's see if we can break that down. So 280 divided by 2. 240 gives me 270. 235. So it's at one pair of 2s. So I left 2, 5, and 7 in there. So if I multiply those, I get 7. So my opposite side is 2 square root of 70. And we froze up here. Give it a second. Yep. So, opposite, hypotenuse, adjacent, hypotenuse. One more quick thing if we're in quadrant 3. This will also be a negative. Let's go ahead and throw that in there now. And then opposite over adjacent. My bad, right? Meant negative 3. That should be a negative 15. So we're actually going to have to redo this problem. Let's go ahead and fix that now. So these are all totally incorrect. Although our method for finding them will be the same. Sorry about that, guys. Everyone makes mistakes. This one, we'll get 64, which will just give us a nice number, 8. So this is actually just going to be negative 8, so that simplifies things a tad bit there. So now, so negative 8 over my hypotenuse, adjacent over hypotenuse, and then over A. Real quick, let's simplify this one. So we know that these are both negative, so it's going to be positive. 8 over 15. And then flipping on this end. And we know we get a positive as well, so 15. So that's about it for our notes for this unit. We've covered everything we need to ensure that you have the correct work down here at the end. At this point, you need to move on to your practices and make sure you're checking your answer key, asking me any other questions. And then we will be moving on to a review and exam for Unit 7.